Hello my friends, welcome again to my video channel. Today we will start a new project, antenna tuner MFJ model 993B. It's an automatic antenna tuner for the shortwave range. The owner, a member of our local amateur radio club, told me that there's a problem with the frequency display. The tuner indicates the frequency and tunes automatically to the frequency for best antenna matching. So let's see what the problem is. First step is to make myself a little bit familiar with the operation of this automatic tuner. I connected a small transceiver, it's my portable transceiver. Maximum is 10 watt output. This is a dummy load 50 ohm, I have another 50 ohm I can connect in parallel, so I have 25 ohms to check the tuner. What's going on? The manual is rather thick, but it's not so complicated. Switch it on. Obviously it's a greeting. It says hello. Frequency is 0 megahertz. Up to now no signal. I tuned the transceiver to 14.200 megahertz. Mode CW. I key it. Can also be done with the microphone. When there's no keyer connected, then the input of the key connection is shorted to ground, and then we have an output. Okay. There is no reflected power, of course. We have only 50 ohms. When I go to the 25 ohms, we have a little bit on SWR, but there is no tuning, automatic tuning. And there's a problem with this tuner. There is a rather high threshold and target SWR. So for SWRs below 2, there is no automatic tuning, and it should be done by hand. Okay. Wrong direction. That's it. I check the target SWR. I can change it with tune and see up simultaneously. This is 1. This is 2. I set it to 1. This is a target. It is still 2, but when I switch it off and switch it on, then we have target of 1.5. Okay. The operation is a little bit strange. Maybe I should read the manual more carefully, but still I have the problem with the pointers. They are not stable. The output of my transceiver is stable, set to approximately 5 watts. We have full scale 30 watts. We have here 5 watts. I can increase it to 10 watt. So we can see it a little bit more. This is not nice. I will connect my scope to the output and see what's going on in the signal path. I connected the scope parallel to the output, so I'm measuring the voltage which is across the dummy loads. When I switch on, I can see still the jumping needles, but the output is absolutely constant. As you can see, when I reduce the output, we still have the jumping needles, so I'm quite sure that the problem is not in the signal path. I assume the problem is inside the tuner, contact problem. It's important to know that this SWR meter is not driven directly from the SWR bridge. Inside the SWR bridge, the signal after the diodes is fed to the processor, to the AD converter. It is converted there, calibrated. Of course, there are some calibration points, and then the signal is fed back to the instrument as an analog signal. Looks a little bit strange. I hope it's not a problem in the processor part, in the microcontroller part. but we can see the details. Here we have the standard SWR detector. It's fed to the controller, and then the controller feds the signal to the SWR watt meter. And then the modes, whether we have power mode or anything other, is specified in the microcontroller. So obviously here we have no problem with this path. The problem is here or anywhere else. Maybe the sensor itself has a problem, a ground problem. Anyhow, I will open it and have a look into it. It's open now. It's easy to get access to it. The mechanical construction is, as we know from this manufacturer, it's acceptable. We shouldn't expect too much. The board is okay. I don't see any problems with this capacitor. Solder connections on the outputs of the antenna connectors seem to be okay. This is close to a short circuit. Well, but it's not a short. Here we have the output for the balance, antenna 1 and 2, and the balanced line, transformer relays, switch capacitors, switched inductors. Here we have the SWR meter. First thing I see, what I don't like, this wire is squeezed behind this metal bracket which holds the instrument. I cannot take it out. I have to remove the screw, loosen it. Here we have the ground connection. Oh, is it loose? Here, this pin. I'm not sure. This side also, the solder connections here are a little bit weak. Okay, can we solder it? No problem. I will take out this wire here, unsqueeze it, and resolder the pins. I will solder the pins on the instrument, but still we have the problem. So it was not what I thought. Next step is I will measure the output voltages of the high frequency bridge. No fear, it's not dangerous. I only have 10 watt, so the voltage here are not so dangerous as when we would operate it with 100 or 300 watts. 10 watt is a little bit more convenient. This is reflected in forward power, and I will use my analog voltmeter, and this voltage is constant. It's in the range of 50 millivolt, and forward we have 500 millivolt, but it is also stable. This flickering cannot be measured on the SWR bridge, so it has to be, the reason has to be anywhere else. I'm measuring the power supply. The 5 volt is okay. This input voltage, what is it? 13 volt, of course also okay, but important is the stabilized voltage, which is 5 volt, and it's also okay. And while I was checking the voltages, the supply voltage, I have seen that C1012, it's the filter cap on the incoming side of the voltage stabilizer. We have here the voltage stabilizer with the incoming cap. You can see here a small brown spot, and when I bend it away a little bit and I looked under it, this cap is leaking. Again, a leaking cap. I have to take it out. Maybe this is the reason for the problems we have. Maybe the acid damaged some traces. I have to take out the whole board. It's not so difficult, I think. I only have to unsolder all connections here from the plugs, from the antenna connectors and this ground connection. And the front, I don't have to unsolder it or so, because I can take away the front panel. There are screws, 2 screws on the front. You can see here and here. So I can take out the front, and then it's possible to lift off the whole board together with the front panel. And then I have access to the lower side, and I can see the damage what was caused by this leaking cap. Now I can take out the main board. It's rather easy, just to loosen the screws. There's a strange sort of glue in it. Maybe it's to fix the screws, I don't know. But now I can take it out, flip it out, and have a look at the faulty capacitor. I can see a rather strange trace of, what is it? You can see it from here to here, down over the contacts. Don't know what it is. It begins at this hole. There's a screw in it. Goes down here. What is this? Strange. Don't know what it is. The other screws have not this problem. I will clean it. I could clean this trace with some, you can use alcohol, I use some gasoline. It's also okay for this purpose. But I've seen the pins of the relays are bent, and they are very, very close, very close to the ground. So I will shorten them, clip them off to make the distance to ground bigger, because this could make some flashovers when using high power. I have the same problem with the trace from here to here. It's not electrolytic from a cap, but this is a microprocessor here. The pick, what is this? I don't know. Looks like grease or so. Should be a glue. I have to clean also these contacts. Maybe this is a cause for the problem, because the pins may be shorted, partially shorted. This could cause a problem with the SWR indication, because one of these traces here is the output, which goes to the SWR meter. I will clean this also. Another problem I've seen, it's hard for me to be neutral about the quality, but I have to say this. This pin is here. You can imagine this board flipped by 180 degrees. Okay, this is this, but this is not this. This stud here gets in contact with these pins here, and here we have the input of the power, 12 volt DC power supply. Here is a relay. In other versions here is no relay, luckily, so this short circuit caused by this stud is not a problem. It's not causing a problem, but this should be here in line with this hole, but it is here. Don't know why. Different version, nobody thought about it. Old case, whatever. So this is a design flaw, a big design flaw. Shouldn't happen such a thing. Ugly. But first I will clean this hole and the trace, whatever it is. Next step is I take out this electrolytic cap, which is leaking. Can be done from the bottom side. This electrolytic is out. We see some signs of leakage, but luckily there are no fine traces underneath, so I only have to look for the vias. You see the last pin, which is not present. Okay, I will check the via and replace it by a new one. The cleaning was rather easy. Luckily there was no acid under this, I think it's hot melt glue, and didn't damage the fine wires or traces. The via here is destroyed, but it's not necessary because on the bottom layer there is no connection. The connection is in the top layer, so I will connect the capacitor here directly on the top layer. This ground connection is okay. The acid was only here in this range, so I have cut the you can see, cut the wire and made it in a rectangular angel, so it is flat on the surface now when I solder it in this way. The new cap is in. By the way, I used a little bit a better type, 105 degrees Celsius. The old one had only written on it 85 degrees Celsius. The new one is better, 105. So I think it should last much longer. Okay, I cleaned the board on both sides, and now I have to clean all these studs, threads, and I decided to move this stud from here to here as it should be. So the hole here has also the option to install a screw. It's important here to have a screw to support the PCB, because here we have the connection for the remote control and for the power supply, and this connector here, the 9-pin connector, has no connection to the chassis. In the chassis there's only a big hole but no screws on the side, as it should be. So all mechanical stress which is on the cable is directly fed to this connector and fed directly to the board via the soldered pins. But soldered pins are not good for any mechanical stress. There is a strain relief missing, should be there. It's a bad construction. So at least this support is necessary. To locate the hole, I fix the board in place as it should be, and then I go through this hole, mark it, hope it's correct. I do a second check. I will measure the distance from here to here in parallel with the case and see whether we have a coincidence. And yes, I think there is a coincidence. It's exactly here. I will drill a hole in it and fix the stud from here to here, remove it, and then we are in the right place. It's exactly on the straight line from this hole to this hole, as expected. It's in one line, so that's okay. The new screw is in place. We have the new hole, which fits. This is the old one, the wrong one, that's the right one. All connections are made again. All antenna connections are soldered. Front panel is in place. Now let's have a try. And now same check again. And we see we still have the same problem. Sometimes at some power levels the pointer is very stable. especially at higher levels. Okay, this is approximately 8 watt or so. High is relative, but now we see it's stable. But when I increase the power a little bit more, again it gets unstable, especially the reflected power, and I have an assumption what the problem is. My theory is that the problem is the AD converter in this PIC. The PIC 16F76 has only 8-bit. 8-bit is okay, this resolution is high enough for such a purpose, but we have the problem that the input voltage from the SWR bridge is not linear. With increasing power, the voltage, which is here in the vertical axis, is nearly zero until the threshold of the diodes is reached, and then we have such a characteristic. That means, assuming we have here a linear scale for the AD converter gets a signal from the SWR bridge, the voltage. So we have here constant steps, 1, 2, 3, up to 255, starting with 0. These linear steps here are not linear with the power. That means the first steps, 1, 2, 3, have a rather high power. A difference from here to here, from here to here, and with higher output power, the difference between the steps is getting nearly 0. And this would mean that when we have an uncertainty of the AD conversion, we always have an error of plus minus 1 bit. So we have here jump whether it is 0 or 1. That's the rather high jump, or 1 or 2 or 0. So when we are here, the power indicated is this, or it is this, or it is this. So we have here a rather high error caused by the bit error. And when we have here an error in the bits from 253 to 54 to 55, then the power difference is nearly 0. That means the sensitivity in the low power range is rather high for such an error. Now I will check it with higher powers in the range of 100 watt and more, and see what's happening. Here we have the watt meter up to 200 watts, 100 watt, 50 watt, 10 watt. I increase the power. By the way, I have a load of 25 ohms, 2 dummies in parallel, so we have 25 ohms. When I increase the power beginning with 0 up to 10 watt, we are in the low range. We still have the flickering display, but this instrument here is okay. When I go to SWR set, should be set to 100%, but we see if this pointer is also stable. And when I go to read, we have 1.6 or so. Stable. This is not so stable as it should. When I further increase the output power, for example here we see still flickering. When I further increase the output power, the instrument switches to the 300 watt scale. That's also okay. Now we have 50 watts, a little bit more than 50 watt indicated here. And now we have a rather stable display. Okay, this is a problem with the transmitter. When I increase the power too much, into 25 ohms, the ALC, I have indication of the ALC on the transmitter, so doesn't like it. I will go to 50 ohms and reduce one of the dummies, or remove it, transmit again, and now we have more than 100 watts. $100 watts, 100, that's okay. That's my key. I'm operating CW. Seems the key is a little bit dirty. But we have now rather stable indication. $120 watts, Yes, when we go down to the lower range, okay. That's it. I think this problem is part of the concept. The AD conversion, that's my opinion, is a weak point. So I cannot find any other fault. It is as it is, or what you see is what you get. When you buy such a tuner, don't expect too much. Now we are at the end of this project with this little automatic antenna tuner MFJ993B. We had a leaking electrolytic cap, but this didn't cause problem. Luckily there was no further damage. The PCB was not damaged. It was a rather dry leaking capacitor. There was maybe a problem with the solder connections of the SWR meter here, where we had the flickering, the non-stable indication, but I think it's not the solder connections, it's a design problem with the AD converter, which is only 8-bit. And this 8-bit spread over the range of 300 watts, and when we are operating in the range of some watts, 5 or 10 watts, then maybe we have a problem with the resolution with the AD converter. Additionally, we had a mechanical problem, a design flaw, a wrong hole, a wrong bolt or stud. So this I could drill a new hole in it, so it's okay now. The rest, I think, is only a question of operating, of setting the threshold and the range of the SWR, the tuning range. This is a little bit weird, but I think it's okay as it is. I can't do it better. I can't change the concept. That's it. Stay tuned, stay healthy. See you on this channel.